Hello, everyone. Welcome to today's webinar on service virtualization, fine-tuning your performance test. I'm Pamela Deason, Head of Application Development Product Marketing here at Broadcom. Today's presentation is going to be led by Beverly Mendel, Product Manager for Service Virtualization, and she is joined by Andrew Gates, Global Capability Specialist. During the call, if you have questions, please use the tab at the bottom of your screen to enter the question, and we'll take some time at the end of the call to make sure we review them all. Now I'm going to turn it over to Beverly to start the presentation.
Hello, thank you, Pam, for the great introduction. Hi, everyone. Thanks for joining us. We'll talk today in depth about performance testing and using service virtualization. We'll talk a little bit about the high level around the background for this, and then we'll jump into talking about best practices for your performance testing environment, actually fine-tuning the environment itself, the VSE, fine-tuning the services, and kind of reviewing how you would troubleshoot in terms of recommendations. We will have time at the end for question and answer, but we'll try to answer questions as well throughout the presentation. So as Pam said, please do enter your questions in so that we can, one, you don't forget, and so we can also talk to them during the presentation. And so without further ado, I'm going to jump into kind of the value of using service virtualization to help with performance testing. And to set a little context, right, performance testing is an entire discipline. When we say performance testing, customers are often talking about a lot of different types of tests they're doing, depending on what they're trying to test and what they're trying to solve. And so we've got things like load testing, stress testing, soak testing, right? Different kinds of testing depending on what you want to see, right? Are you trying to understand the behavior under the expected load and where are your bottlenecks? Or are you trying to really test the system at the highest peak load and try to figure out like what is the upper limit that the system can even support? Or are you trying to do endurance tests or trying to test individual components and see how each component can handle? And so there's a lot of different types of performance tests. We're not going to go into the details of how to design or what type of performance test you should do, right? That discipline is there to help you and to guide you, but we're going to focus more on, now that you know what type of testing you're doing related to performance testing, how service virtualization can help you with that. And as you're designing the types of testing, of course, you're thinking about your application in mind. It's really important to test your application under load, because when it's in production, you don't want to run into any challenges. And people are not patient. They're not going to wait for your application to perform. If things are not working as expected, they're going to probably go away, right? They're going to leave. They're going to go do something else. They may not come back, right? And so this is something that obviously your applications need to perform at scale. And some of the challenges that are exacerbated, right, when you're trying to release frequently in an agile process, is you really have to make sure that your testing practices align so that you're able to performance test earlier in the cycle, even if you've got complex applications in terms of interactions and environments, or things that might be expensive, whether you're calling a third party or something else. And that's sort of what we see are some of the challenges, right? So can developers test their code, performance test their code early in the cycle? And we see that few developers do, right? We see that performance testing is often done at the end or later in the cycle. And how do you shift that so that it's earlier? We see customers or folks tell us that if, prior to using service virtualization, they had to scale down their tests. So based on the environment that they have, right, a performance environment that truly matches production can be incredibly expensive. And so they might not have that if they want to shift their testing earlier. And so they have to instead extrapolate. Do a test at maybe 30% of what a typical load would even be and extrapolate the data, but that might not actually be how your system would perform under that real load. And they might not test certain scenarios, especially if you have things like negative scenarios or hard to reproduce. Some of those scenarios may not get tested. And so it's really with these, challenges, what you see is if testing is not happening until the end, you might discover problems later on. Timelines may slip. You might not know, and you might have to do a lot more troubleshooting on which component is actually broken because you're not testing each individual component in an isolated manner. And you might run into some performance issues in production as well if you're not testing the scenarios that you need to. So these are some of the challenges that we typically see in regards to performance testing. And so this is where we talk about service virtualization. So, as you're familiar with the concept of service virtualization, right? You can stand up virtual services that represent a downstream system, and it can represent multiple downstream systems so that your system under test will get the response that it needs. So if I'm testing the ESP system, I could stand up virtual services to represent some of my backends, whether it's because they're not available, I can't get them to be large enough for the load that I'm trying to handle. I want to test just my individual component. It might be expensive, like a mainframe or an ERP system. It might be hard to get the type of data that I would need in the system in order to test. It needs to scale the way I'd like. So all of those things are why I would design. I could have applications, our application test system, or I could use another system to push load onto my system under test, and then my backends I could represent with virtual services. And the benefits here is, first of all, I can performance test earlier. And I, as an application team, can performance test my component. So I can know before I've got an integrated system test that my component is going to perform the way that I would expect. I can scale my performance tests to meet what I would expect in production rather than having to do something like some sort of extrapolation or have to pay huge fees and hardware and software costs, et cetera, in order to have an environment that's truly production-like. I can design my tests, so depending on the types of performance testing, to meet what I need, so I can ensure that I have the coverage that I need. And that will include being able to support hard to reproduce scenarios, negative scenarios. What if a certain system is slow? Will it cause, what kind of bottlenecks will it cause? So if there's specific scenarios I have in mind that I need to test, I'll be able to handle those as well with a predictable way. And when we think about, some of the architecture out there, especially with microservices, there's a lot of interdependencies between components. And so if I have a specific SLA on the component that I'm working on, but I might have multiple services that I have to call, in this case, verify and a lookup and an inventory service, all those services also have their own SLAs and SLOs. So in order to truly test my component, one thing to keep in mind is you're probably going to want to make sure that those services are not just responding as fast as they can. That doesn't really tell me if my component is going to meet its SLAs and SLOs. I want to give it a realistic behavior. So I can give it its expected. I could say, what would it be in the high end? I could give it a range. But I want to make sure that when I'm performance testing my component, and especially in making sure that you meet SLAs and SLOs, that you provide a realistic look. And so that's sort of the high level background. And you could represent those with virtual services. We're going to now talk about the actual best practices involved and get into the weeds of really troubleshooting. So Andrew, I'm going to pass it on to you.
Thank you, Beverly. And my name is Andrew Gates. We're going to talk a little bit about some of the best practices at several levels within service virtualization. We'll talk a little bit about how to set up our environments and architecture at a broad level to support an excellent performance test, and then get into things such as how to tweak our virtual service and how to tweak our underlying infrastructure to provide us the most performance that we need to complete our goals. Now, when using a virtual service, service virtualization instance to support performance testing, you should be aware there are two types of two endpoints of performance test that we support. We do have our app test functionality, which provides the ability to generate load, very similar to other products in the field. It allows us to push transactions, monitor transactions, and implement test cases and what we call staging documents and test suites, and generally drive transactions. But what we're going to focus on today is the support for virtual services to support performance testing. Now, when you have a performance virtual service environment, the goal is to support as many transactions as possible. And to that end, usually your transactions are going to run fairly high, use a lot of what we call concurrent capacity, and generally run transactions in the scale of hundreds of thousands to millions, depending on the transactions per second that you're going to be shooting for. Now, a standard install of service virtualization comes with what we call our functional license. Now, our functional license supports 10 concurrent connections at a time, and is generally designed to provide support for individual testing teams to do functional testing, to do test coverage, and the like. Because it doesn't have the same scale of transactions as our performance virtual service environment, it's usually not the most appropriate for a full-scale load or performance test. For that, you need our performance license. Now, our performance license removes all the limitations upon concurrent capacity, on transactions, anything that you need to allow you to execute as much testing volume as you need. So here we're looking at the standard test harness we use when we release a new version of service virtualization to benchmark what a performance server should look like. Within the documentation for service virtualization, you'll find sample benchmarks for basic service testing, for asynchronous messaging testing, and generally what it provides is this is what we recommend as a baseline for a performance setup. So what you're looking at here is that we do run our performance server on an enterprise database such as SQL or MySQL. It uses a separate registry coordinator and simulator to provide the transaction hub, coordinating and deploying out threads as we need. It has a performance VSE that we set up in a separate instance. Now, the performance virtual service environment is what's going to give you that horsepower to run through your transactions. And then we have some type of load generator. Now, with the numbers that we're going to look at, they were generated using JMeter from a separate install inside the development lab. For the demo that we're doing today, we're actually going to be using our own application test within service virtualization to run the load. So the numbers will be slightly different. And to give you an idea of what a performance test will look like, these are performance tests that will run over an hour in length. The thing to be aware of is that depending on how you set up your performance test, the size of the transaction will really have a large effect. So for example, here you have a 1 kilobyte size transaction, a 10 kilobyte size, and a 100 kilobyte size. And those variations will generally affect the transactions per second that you're going to be getting from your instance. Now, one thing I do want you to note is that if you look at the memory utilization and CPU utilization, you'll see the balance that you'd expect in a standard performance test. And you'll note that that really the bottleneck here is going to be the CPU. Now, the memory utilization was fairly stable for REST transactions. So if you're looking at your server health as you execute a transaction, and you're finding that your memory is pegging the needle, for example, is reaching 90 or maybe even reaching full memory utilization, and your CPU is not fully engaged, then some of the troubleshooting and steps that we're going to go through will really help you get that balance. So if you're looking at a healthy performance test, this is kind of the balance you want to see. All right, so what we're going to take a look at with our example is I have set up several performance tests over the last week that use a harness similar to this. You'll note that we're using our dev test workstation, our registry, as well as coordinators and simulators to drive tests. Now, if you're familiar with the app test portion of service virtualization, this is basically running. Oh, yes.
Andrew, I'm so sorry to interrupt you. We've had one person report that they cannot hear and they're having trouble. All they see is the title screen. Can I please poll the audience and use your question In order to ask questions, just use that tab to respond. Can you hear and do you see the screens going, from slide to slide, or are you still on the title slide? Can someone in the audience respond and let us know that you hear us or see the screen?
Oh, there. I'm seeing someone has an actual question.
Okay.
Before we get to that question, please, from the audience, we just want to confirm that whether or not this is a broad issue or if folks are able to hear and see. So someone confirmed they can hear. Are you also able to see the screen application test for performance testing? Can you see that slide?
Yep, everyone. Okay, great.
Yeah,
okay, so Pam, maybe you can work with that individual. Sorry.
I will try. Yes.
All right. Sorry, Andrew. Can you continue on?
Not a problem. Let's go ahead and parking lot the questions for when we get to the end. So we'll go through the demo, and then we'll speak to latency issues. And actually, that's actually one of the issues we'll talk about within our troubleshooting piece. So what I want to show here is really quickly is how we're doing the load for these performance tests for the numbers you're going to see. So we'll go ahead and share out the screen, and we'll take a look at what it looks like when using service virtualization. And we're just on it, and what we're on is just a standard service virtualization install. And let's make this a little bigger so we can all see it appropriately. Now, within the dashboard, you'll find, for example, if you're running performance tests, that the dashboard will tend to give you information that during a functional test would be most immediately useful. The thing with using a performance test is oftentimes you're going to be running millions of transactions through. So you'll start getting numbers where you'll see, for example, you'll note that I ran in the last week about 7.4 million transactions through my service virtualization services. And I've been running tests that not only are performance tests, but also tests that I've designed to fail as well. And we'll walk through those when we go through. Now, when running a performance test, what you're mostly concerned with is, do I have a performance virtual service environment that's usable? Now, generally, when you roll out a virtual service environment, it could be using a license for a functional service environment, or it could be using performance test. The easiest way to verify what type of service environment you're using is to come under your monitor to your server health. And in your server health, you'll find listed all the components that you'll use. Hold on just a moment. Let's make that a little bigger so we can actually see this. So for example, I'm listing my registries, coordinators, and simulators that I'd run my test load with, but I'm also listing my virtual service environments. Now, within these various individual virtual service environments, if you come to the far right, you'll find whether the performance mode is enabled or disabled on that particular virtual service environment. Now, where a performance mode becomes important is when we're ready to deploy out, say, for example, a virtual service that we want to use to support a virtual service environment or a performance test. Give me just a moment as we refresh this. Hold on, I just have to log out and log back in. All right, and there we go, manage our virtual services. So when we are using our virtual services here, for example, this particular virtual service is what I was using for my performance test. What you'll notice is when you deploy a virtual service, if you choose a performance environment that is not a performance-enabled environment, you'll get the standard deployment options of group tag and think time scale. Then if I actually select for a performance environment, I'll get a new field called concurrent capacity. And that will come in if you're using a performance server as well. Then from here, I can do something such as enable so many concurrent connections for my particular virtual service. I like to bring my think time down to 0 when deploying a virtual service for performance test, and I can deploy out normally from there. Now, when you use a virtual service in performance setting, what we're trying to do is push as many transactions as possible as we can. And we're going to have several tools available for us to figure out what exactly is pushing through. If we go, for example, to monitor our virtual services, in the virtual service environment. And come here. Within these, I can actually see how many transactions have flowed through. Now, since I just pushed out this ATM search, of course, it zeroed out the counter for what we're doing. But if it zeroes out the counter, we actually have a lot of reports under our virtual service metrics to help us determine how our performance test is running. So if we come over to our virtual service metrics, we'll actually have things such as our transaction daily counts, which will show us, for example, that we ran 3 million transactions in the last few days through this particular virtual service. And we have our virtual service transactions per second, which will allow us to figure out what we're running through our system and whether we're reaching our target goal. Now, what you're looking at here, and let me move to something a little more clearer, is actually a set of tests that I've ran over the last day, showing some modifications as we've gone through. So generally what I'm running is just several REST calls to our digital banking application. These REST calls go out and they get back zip codes and address information. So they're a fairly simple service that we're calling. Now, when we start a performance test, it does take a little bit of time for us to ramp up. But when we ramp up and hit our peak, we want to try and, if we're trying to reach certain TPSs, we need to understand what's kind of going on behind the scenes. So for example, you'll see that I ran a test that I'm reaching about 4,000 transactions per second. Now, what's happened here is I've actually set my concurrent connections to something like 50 or 100. Now, this allows the system to try and use as much of its horsepower as it can to provide virtual services. But my goal was to try and reach near to 5,000. So what happens in a virtual service is there is a bit of overhead for when, say, for example, accepting transactions via a concurrent pool full of threads. Those threads have to be instantiated and then those resources returned back to the system. So oftentimes you can play with the amount of transactions and find a sweet spot that your system is going to be most efficient using those amount of transactions. For example, when I was down here at this 3,500, I was actually using 100 concurrent transactions per second when I deployed out my service. Yet, when I tuned back my service to 20 transactions per second, ironically, my TPS went up. And the reason for that is at 100 concurrent connections, there's a little more overhead that's reducing my throughput by about 10%. So since I knew that I was trying to find my efficient sweet spot with my deployment, I finally upped it to 35 transactions per second and was able to get near 5,000 transactions. Now, what you might have noticed earlier is that our numbers that we're producing with our in-lab systems were coming in with small documents at about 12,000 transactions per second. Now, what was going on there is that was a dedicated lab environment using dedicated standalone systems with on-site storage. What I'm using here for these tests are containers within a Google Cloud instance. And something to be aware of when deploying out those containers is you're going to have certain limitations based upon if there's any cloud wall hops that you're doing. For this particular test, there are not. I'm actually running systems connected to each other within the same Google Cloud instance. But I'm also using the hard drive provided at standard level within my Google instance. So you need to be aware not only of network hops, concurrent capacity, but also of memory, of backend hard drive, even what type of network. If you're using 10100 if you're using older hardware on a 10100, if you're using fiber channel, all of these can have some effect on the TPS moving through the system. And one way to really understand how if it's your test or if it's your infrastructure is to take a look at your server health. So I pulled up, I captured a screenshot of the server health while running my test last night, and you'll notice a couple things. My test harness, which is sending the various transactions, is running about 80% system usage with about 20% of JVM. But my virtual service environment, my performance server, is running at 62 JVM and 62 CPU. So what this is showing is that my CPU and memory is running extremely efficiently, but there's a lot more going on in the back end that I can potentially find more space. I can and in this case, when I went into Google Cloud, I found that it was my hard drive that was caused me limits in connection. The other thing to think of, and I see the question in chat actually, is that what are you using to run the load test as well? So if your backend services and infrastructure are well scaled to support this test, and you're still not hitting 80% CPU on your performance server, look at what you're using as a test harness to drive load. And again, since I'm using an application system that's generally running at 80%, I can be fairly confident that my load system is running at its pretty high level for what it is. But if you're using something like JMeter, you might get a little more performance as well. So those are some things to kind of keep in mind as you're moving through.
And Andrew, I'm going to add in, right, that I realize that many organizations already have a solution on what they use to drive the load, right? And so what you're driving the load against the application, you're able to use that. And so basically service virtualization will then substantiate, the back end of what that system under test is calling. And the closer that you drive it to the application that you're testing, the more effective that you're going to get. So I just wanted to clarify, right, that it's not dependent on what system you're using to drive the load, although that may influence some of the results that you get.
Thank you very much, Beverly. So another thing to think of too is when running these loads is that what part of your particular application you're testing against. So for example, we'll come back to here again. These are the reports that we're looking at for when modifying concurrent capacity. I also ran a test. So the application I was testing against was an N-tier application with a web front end, a set of business objects in the back, and a database layer. And you can see the difference when I point at different parts of the particular application. So you'll notice I'll get these spikes here because what I was doing was I was testing against the web front end directly, which had a limited capacity to accept connections at the speeds I wanted to. So what you'd get is it would queue up several thousand transactions, and then the web application itself would queue and slowly process through them, keeping my TPS down and not letting me move through the test as fast. When I redirected my performance test to directly address the enterprise services in the back end, you can see how the transactions would increase, giving you a more efficient load of services that you're testing against. That's something to keep in mind when you're trying to what portion of your application do you want to test? What pieces are you trying to stress? And understand that the limitation of what you're stressing may limit what you're looking for when you're SLA. Okay. All right, so let's go back to here. I'm going to end that screen share and come back to the slides. All right, so I'm seeing a lot of questions. Beverly, should we run through the questions or should we go through the fine tuning first, do you think?
I think let's go through some of the fine tuning and then we can go through some of the questions.
Okay, perfect. So we do need to see your questions and we're going to get to them here in just a moment. So I want to talk real quick about some of the fine tuning that we can do at the environment and architecture level, as well as the virtual services as well. So within fine tuning the environment, the minimum requirement that's in the documentation is for a 2-core 8 GB system. The numbers that you saw earlier for our benchmarks were used as the most common build, which is a 4-core 16 GB system, which is also the same level of system I used within our Google Cloud. But we do have customers who use very large systems. I've seen myself in the wild. I've seen 8-core 32 gig systems, and it's designed and focused on the performance test. We have customers, for example, who will do nightly regression tests say, for example, testing a nationwide ATM network, using our performance servers to drive load and be able to verify before code release that that a large transaction-based network can take the load that's going to be passed to it in a production or real-time environment. And oftentimes, what you'll see when trying to build out a performance test is that that the bottlenecks usually come down to either memory, or that that they might try and be building out a performance server on the fly with, say, for example, default containers or pre-built instances. I've seen some customers who will be using a cloud setup like we are here, but they'll be limited in what instances they can deploy out. They may be limited on cores because their default instance only allows 2 cores, or their memory footprint might be lower. Performance VSEs, you want to give as much memory and as much power as you can, because when you give it that power, you're going to scale higher. And if your goal is to reach, say, 5, 10,000 transactions per second, you're going to want all that power to be able to accept, process that transaction, and move on to the next as quickly as possible.
And I'm going to stop really quickly. I just want to add one more clarification based on a question that we have. So, we've talked about, and the metrics that we're showing are the the results of the virtual service itself in terms of the response. So, we did talk about how we can also generate the load, but there are lots of tools out there that also generate load. As we mentioned, organizations might be using a certain tool. And so the question comes, how is this different? We're really focusing today on the virtual service side, which is now I need to test my application. It's dependent on probably a complex backend or an expensive to replicate backend or scenarios that I need it to respond with consistently. And so I don't actually need the rest of my environment. I can stand up virtual services. So for anyone who's asking, how is this different? We're not talking here just about substantiating the load. We're talking about, now that I'm testing my application, I'm bringing up virtual services to help support. So I just want to clarify if that question's there, so that when we're thinking about this virtual service environment is actually where you're housing those virtual services.
And to continue on Beverly's point, what we consider large builds, or even our common build, are actually much more affordable than building out, say, for example, an entire pre-production or acceptance environment, and are able, through the virtual services, to give responses at the same level that a standard pre-production environment might do for twice, 4, 10 times the cost, at being able to deliver at a much cheaper price point, so that you can get the levels that you want without having to go buy in a whole other production level environment in order to accept and generate that load. So performance VSEs and performance virtual services can really step in, especially in those expensive systems we talked about earlier: mainframes, large-scale databases, ERP systems that are going to be expecting a large amount of transactions. Virtual services can help you get as close as you're willing to design for those type of performance tests before hitting production environments, especially. So a lot of things to consider when building out a performance server. Always use an enterprise database system. The default out of the box in our service virtualization installs is our Darby in-memory database. We really only recommend that for proof of concepts or for demos. Be sure that your systems are using, say, a SQL or a MySQL, Oracle, some type of back-end enterprise database in order to properly support the amount of transactions that are going to flow through a system. Make sure there's enough memory within, and we'll talk a little bit about diving into configurations for memory here in just a moment. But the default standard 8 gig is good enough, I think, for doing a developer-driven on his desktop performance test. But when you're ready to start doing the hundreds of thousands or millions of transactions, you do want to try and get up into that higher memory range, at 16 to 32 gig if possible. And of course, with knowing your application, this gets back to be sure that you're testing at a spot in the application that meets your performance, going to be able to meet your performance goals. So I've seen a lot of customers who will try and test, say, for example, at the web front end, trying to reach their SLA of several thousand transactions a second, and their particular web server, for example, or their web application server just can't handle that type of load. If you're looking to test your services, it's oftentimes more effective to run your performance test against your ESB rather than through your front end web page. And of course, know your architecture. Know that, for example, if you have an application that you want to test that's being cloud migrated, know that where that application lives. And if your test harness is existing on on-prem services and trying to test against a cloud application, understand that the round trip, the milliseconds it takes to reach that cloud system might add a lot of time and a lot of round trip to your performance test. Keep going forward here. There we go. When you're running a performance test, especially if you're ready to run your large scale test that you've been planning for, quiet the environment down. Do such things as turning down logging, turning off the application insight, and of course, verify that there are no other test environments running. Oftentimes, your server health tab will be very valuable to this. It'll tell you not only that if any other tests are run, if any other server is under load, you can also see if there are any live connections to your various registries, coordinators, or even VSEs. Also, use your monitors within your dev test portal to verify that there are no other tests still in flight. Oftentimes, if you have a long-range test, sometimes they're not ended cleanly. They might still be open upon this service virtualization. That's something to check for to make sure that you're running with the most efficient resources you can. So memory and garbage collection are very important because a virtual service is deployed into memory inside a JVM. So to get the most performance out of a virtual service deployed out, you want to make sure it has access to the most memory possible. Now, you can use your VM options for your coordination simulators if you're using dev tested drive automation. But if you're using virtual service environments, then be aware of your virtual service VM options and the ability to add mins and maxes for your JVM. The ability to modify how garbage collection occurs within the particular JVM that you're running your virtual service at. And oftentimes, that limit will be just dependent upon the memory that you have. I do recommend when running a large-scale test, use as much as you can. If you only have access to 4 gig within a JVM, then use all 4 gig. If you have access to 8 gig, then use 8 gig if possible. So that's something to remember with a virtual service, is also to be aware of your JVM's limitations as well. And there's a series of other settings, oftentimes in our local properties that are deployed out that we do recommend. Oftentimes, the overhead that comes from millions of transactions coming into a virtual service come down to how we manage our pools. Are we using connections? Are we spending extra resources to stand up and stand down connections that, because we're in a performance test that might be very repetitive, could potentially reuse already deployed resources? So modifying connection timeouts, making sure that they're there for reuse. That can really accelerate your performance test.
And Andrew, let's take a minute and answer a few of the questions. We might not get to all of them, but there were some questions as well. So I'll get to a few, and we'll continue with more questions later around limitations on, transaction. And so I just want to clarify, right? We are today talking about the performance VSE, but there are multiple types of VSEs. We've got our functional and our performance. The functional VSE is gated. It's gated to 10 transactions per second because that's typically what you would need when you're conducting any sort of functional tests. But the performance VSE is not gated. So you can get to many thousands of transactions per second, depending on how you've configured your environment. And this is where we're talking about how to, best practices around the design. And so you are not limited to the number of transactions, but you do have to have a license for Performance VSE. So if you have any questions, you can also log into the support portal and look at your entitlements. You can see in the enterprise dashboard how many you're running, right? Because it's licensed by copy, concurrent copies. So how many are running it concurrently. And so if you are still unsure, you can reach out, and your account manager can also help you figure out if you are licensed to use that. So the performance VSE is not gated. And so depending on that, you can address that, right? And you'll get the information around the transactions and your usage, both in our reports as well as in the enterprise dashboard.
And one thing I want to note, oh, sorry, go ahead, Debbie.
Oh, yep, go for it.
So one thing I want to note too, depending on how often you cycle your server instances, to realize that the most accurate number is going to come from the reports. So the dashboard gives you a good thumbnail, but to give you an example, this is actually reporting for as long as my portal system has been up, that I've run 7.4 million transactions over the last week. But it's not really helpful for our daily count. For our daily count, we do need to go to our reports, and then we're able to pull from there what we ran for the daily run. So the dashboard itself, so I've actually seen a customer, for example, that had a few billion transactions coming in. It was actually a little hard to read because he had so many numbers within this particular piece. So this is really just a thumbnail. If you want the most accurate numbers, you really do need to come to your reports.
And then there were some questions as well around the benchmarks. And so in our, asking if there was a latency, I'm not aware of any specific latency, but we can, double check with the team that, ran the different tests. But we did kind of share the different settings that we used as well as the hardware and some of the other information. So that is in our documentation. I'm not aware of a specific latency that might have been applied. So I hope that helps clarify it, and we can look at, if there is, adding that as well to the documentation.
And I see someone was saying it was hazy, so it's unfortunately it's a kind of a limitation of BrightTalk, but we tried to. If we zoom in for BrightTalk, and sometimes we lose a little bit of fidelity, but we can work around that too.
Do you want to continue on, and we'll
Yep.
continue with the other questions, as we get closer to the end. Please continue to add questions as you have them. We will have some time at the end for the remainder of the questions.
So within so we talked a little bit about managing memory at the global level, architecture and environment. Now we want to look at the individual virtual services. So as you saw in those benchmarks, the effect of your payload size will have a great effect on your virtual service performance. The difference between a 1K transaction and a 100K transaction is a factor of 4 in our benchmarks alone. And of course, virtual services are very dependent on memory from the JVM. Those are settings we just looked at a high level, and there's something to be aware of as you move through. Now, when working with a virtual service, and if you're hitting the ceiling on your memory, the thing to be aware of is the errors that are going to come are not going to make as much sense when you're exceeding memory. Oftentimes, you'll see Java connection errors, or you'll see unknown Java error. And this is because the system is trying to manage as much as it can with the memory it has. So it's something just to be aware of, that if you're seeing unusual error messages during your performance test, the first place I would look at would be, what is my memory at? If I'm still using only 1 gig of my JVM, then it might be a good idea to up it to 2 or 4 gig. The other thing, as we talked about earlier in our demo, concurrent capacity is efficient to a point, and if you have too much concurrent capacity, it can cause a bit of drag on your performance test. So for example, when we were looking earlier, I had 100 capacity, but I was actually running 10% below my maximum. When I tuned it first to 20, then 35 connections, I was able to find that sweet spot in my concurrent connection. But that is very dependent upon your system and your resource availability. So oftentimes you're going to have to kind of work and find what works best for your system. We generally recommend starting at about 10 connections, seeing if that's working with your CPU and memory usage, and then upping it to the point where you're happy with. And just be aware that if you're going too high, that could potentially impact your performance test. Now, with match style, what I want to talk about here with match style is we have several ways of interacting with our virtual services. So virtual services by default will create a match based on, say, for example, we recorded or created when we built the virtual service. But there's several types of responses. We have, for example, our meta response, which will actually just examine the signature of a request and match that way. So when you're in a virtual service, it's actually possible to build a virtual service that has very few exact matches and just use the signature match as kind of a happy path to accept requests and return responses. The reason being is if you have several dozen or hundred exact matches in a particular virtual service, the system is going to try and work through and match those services. So trying to use, say, for example, a virtual service we built for a very complex functional test and use that as a basis for a performance test, we need to make sure that we go in and basically smooth out the virtual service so that it is as responsive as possible. And again, it's being aware of what do we want to do with our performance test. A functional test is very different from a performance test in that in a functional test, our goal is to get coverage and get quality on as many different test scenarios as our test case needs. With a performance test, we're looking to find the best balance of what is representative of transactions that we'll see in production and be able to scale that to production levels. And of course, there are other pieces as well. We can match on just the operation. Often you don't see this very often in performance or functional tests. And we also have our new selective match casing, which uses programmatic methods to match certain pieces. We, again, don't find this as useful in performance test as we would in a functional test. Now, we did have a question talking about, what the think time was on the particular performance test. When we run performance test, what I like to do is I like to take the think time by default. The service will try to deploy out with 100% think time, which means if I've built a virtual service that responds back in 100 or 250 milliseconds, it'll pause until it reaches that millisecond and then send me back the response. When I'm running millions of transactions, that 100 to 200 millisecond pause can really build up and add padding to my transactions that I don't want. So what I usually do is I deploy out my think time down to 0, and that lets it run as fast as my resources will allow. Now, you may be trying to run a performance test that might have a negative case in it, and that's something to be aware of. For example, you could potentially have a test left over in your harness that might have been a bad case or a negative case that you were testing before in a functional test. Be sure to examine what tests you're sending in your performance test, and that, say, for example, a negative case has not slipped through and is causing a bottleneck for you. On the subject of think time and transaction per second, if you're familiar with our data-driven virtual services, you know that data-driven services can be run from an Excel spreadsheet or a comma-separated file. A data-driven service is not necessarily productive for a performance test because the overhead of accessing, say, for example, an Excel spreadsheet, which is technically a compressed file, has to be loaded into memory and then matched. Generally, our testing has shown that a data-driven service will limit you to about 50 transactions per second. Data-driven services are good for when we're looking to make sure that we have full test coverage and that we're trying to get as many scenarios covered as possible. They're not quite as efficient for when we want to run a very large-scale performance test. So there's a lot of complexities into a virtual service. Anything that you add, especially if you've designed a fairly custom virtual service that you've used for your functional testing, if you've added things such as custom script steps within your virtual service model, if you're calling out to various databases or in-memory tables, if you have very complex responses. All of these can increase the complexity of the virtual service and may make it a less efficient performance test. So there is the ability to use any functional test you design as part of a performance test, but just be aware that the more complex the virtual service is, the longer it's going to take to respond, and the more it could become a bottleneck for an efficient performance test. All right, let's just do a sum up here real quick. So when you're building out a performance test, finding your bottleneck is going to be the most important part. Your bottleneck could be anything from your load generation system. It could be within the memory and architecture that you've set up. It could be something as simple as, for example, in a cloud container that you're using some type of default, say hard drive system or a lower class network. Those type of things can directly affect your performance test and might be hard to locate. Again, use your server health. Determine if your performance virtual service environment is using its CPU and its memory to maximum efficiency. If it seems to be very low, then look around your application and you can find out if you're driving enough load. Always make sure that you're using the service virtualization performance environment when trying to do these large loads. And again, you can use your server health to verify that. And then the various other troubleshooting steps that we've walked through. Make sure your capacity is at the right level. Are you able to generate enough load that it can queue up and build the load as well? The virtual service environments will generally run as many as they can, and it's often hard to hit those limits. So, for example, it took me about a week to get a system built out that would use all concurrent capacity, that would generate enough load that service virtualization was actually using all the resources possible. When using service virtualization, the amount of virtual services that you're serving out also become important. So if you are deployed, say, for example, several dozen virtual services trying to support a performance test, just be aware if some of these are needed for your happy path. I deployed out 4 performance services, for example, into an individual performance server. If I have a complex system in the back end that I need to do, maybe look at deploying some of the lesser used services into a separate performance instance, allowing the most transacted services to exist with a performance server, and then supporting the others through other virtual service environments if necessary.
And one thing to note there, I think let's take a minute to answer some of the questions, and then we will go over some upcoming things and answer some more. But with that, right, you want to make sure that you also, part of knowing your environment is that you're not having multiple teams doing performance testing, like Andrew said, against the same performance VSE with the services, right? Because that could cause some challenges and some complexity as well. We have some feedback and some comments as well. And so we'll start going through some of these other questions around the complexity of the virtual services. And yes, the complexity of the virtual service definitely can have an impact on the service, right? The more logic that has to be done in order to formulate the response, in order to get the response out there, the longer it takes. So you will want to make sure that you streamline. It's okay to add some logic, but you want to make sure it is as efficient as possible in order to make sure it is performant. You do want to check that you haven't accidentally put in things like think time that shouldn't be there. Maybe you've used it for a negative scenario and it got modified, and now it's waiting a long period of time, right? So you will want to check that as well. And you will want to streamline so that you have, only the use cases that you need, so that you're not having to spend the time going through logically to find the match itself. So anything you can do to design your virtual services is absolutely what you should do. So if you determine, right, you're looking at the performance VSE metrics and it's not the environment itself, and you kind of maxed that, you've designed it well, it might be the virtual service. So absolutely looking at that complexity is important. And also looking at the size and capacity. There are some other questions around, sorry, I think.
We've got several questions.
Yeah. So there's a question around wanting to understand more about the performance reports. And so, talking about like the load generator may have different reports. So you do have to think about what is the load you're actually generating on your application under test. And whatever solution you're using should have reports on that. The reports we pulled up today that Andrew was showing was on the VSE side, to understand how is the VSE responding. And you can see there's different reports. You can see, hits and misses. You can see the transaction per second and the flow. And so I just want to clarify, right? There's a difference between how are the virtual service, your application is calling something else. How is that responding, and what are the peaks that it's reaching versus what is the load you're generating against the application? So I hope that helps clarify, right? Right now we've been focusing on these virtual service reports specifically, but that's why we're focusing on those reports in this case, is because if you're troubleshooting, right, you're designing your environment, you do want to make sure your virtual service can handle the load, and then you can do the load test and see how your application under test performs. I believe we have answered that one. There is a question as well about if I can have a VSC, can I call one VSC service from a microservice, which is expecting a microservice at the back end. So I think what you're saying is I've got a service, and instead of calling the actual real service, I'm calling the virtual service, if I understand that correctly. Is that how you took it, Andrew?
Yeah. Just making sure do we support all the protocols that we would within with like a virtual service? A performance virtual service is in our view a virtual service. We're just whatever you're going to accept, be it a REST call, be it an asynchronous call, or a microservice call. We support them all.
Yep. So I hope that answers your question, and absolutely, right? And there are different, some customers have things like load balancers or other things in their environment based on their environmental design. But yes, and you could have it call, rather than the live service, the virtual service as well. Again, that might just depend on how things are configured in your environment. There's also a question about, is there a way to better support improving, transaction per second for database-driven or for data-driven virtual services? And so, CSV is better than Excel, but you are going to have some limitations. And when you think about data-driven virtual services, typically what you're seeing is, hundreds or thousands of different data scenarios that you want to test against. And so I would question you to look at, is your performance test really the same as your functional test in terms of what you're testing in the coverage? And can you reduce or clean that up so that there are not as many situations that you need to test? And I think that goes back to the design of the test itself. There may be things you can do to improve it, but you are not going to get to the same performance if you've got, hundreds or thousands of scenarios. I've seen, tens of thousands of scenarios in data driven, right? And you're not going to, that's not going to be performant. You do want to adjust that service and not just convert it over into a performance test. Andrew, anything to add there?
No, and it just comes down to, if you're looking for a performance test that is best representative of your high TPS environment, oftentimes taking a statistical analysis of your transactions in your live environment. Do I have 60% light documents? Do I have 40% medium to high documents or transactions? A performance test, the goal isn't to cover every scenario. It's to best simulate what a real production environment will look like. So that's something to keep in mind.
And you can absolutely have error negative scenarios, but you'll want to, know when those are going to happen and how you're going to support them. You don't want to just have an infinite number of scenarios in your performance test. We're going to stay on for a little bit longer just to answer some more questions. Before we do want to advertise and let you know of a few things that we have coming up. So Andrew, if you don't mind going back, I do want to share that each month we do host office hours. It's the second Tuesday of the month. We recommend that you join. We try to have a topic the first 10 minutes on something we think folks will be interested in, and then we open it up to questions, feedback, comments. It's an opportunity to ask the expert questions, and it's more interactive because you can actually speak up. So please join us for our office hours. We hope you can attend. Can you also, I believe, can you go to the next slide as well? Let's see. We do also have a weekend upgrade program coming up. Our next weekend upgrade is February 4th. And for this weekend upgrade, you would want to sign up ahead of time with support. But it will be a staffed from 9 to 5, I believe, Eastern, will be a staffed weekend so that even if it's not just a severity 1, but if you have any sort of issues related to the upgrade, you will be able to get help on that weekend. Now, we do want to make sure you're ready to upgrade for that weekend. So we review your upgrade plan. We give you best recommendations. You've tested, of course, in a sandbox. But this is an opportunity to feel confident that you're ready for the upgrade and then upgrade your production environment knowing that we are available. So if you're interested in that, please sign up. As I think everyone's aware, 10.6 does go end of support March 1st, 2023. And so we do want to make sure you're on a supported version and have upgraded. I think let's go ahead and move to these questions. You can visit our academy for more resources and information, but let's answer a few more questions and then we'll end for today. There's questions about what about, MQ, JMS, SOAP services, right? Asking about the metrics. I do want to say, I think I don't remember which messaging it is. I think it's MQ, but I could be wrong. We do actually in our documentation also have the same kind of sample benchmarks. It's actually the page right below. So you can get some sample benchmarks as well for messaging services, but absolutely, we see that as a common use. And so just to be aware, yes, that's there. And there's also a question about capacity. Yes. Sorry, Andrew, did you want to take that one?
Yeah. So I just want to clarify that when you're using concurrent capacity, we use some fairly large boxes for some of our performance tests, and 1,000 capacity is not necessarily the most efficient way to even with a single service. Generally, it's going to be dependent upon your resources, but we do recommend that you start at about you need to watch your test and see what's limiting you. Is it memory or is it CPU? With 1,000 capacity, the overhead required to manage those 1,000 connections is actually holding you back. And oftentimes you'll find that either 10 to 20 to 50 connections will run a faster test than 1,000 connections, as an example. And the reason is the CPU is efficient enough to move fast through those various threads for the transactions. So just be careful when trying to get to a high concurrency that the capacity itself may be a much lower number than you expect, only because it's very efficient to manage a smaller pool than it is to create a large pool.
And we've seen, people use capacity with 5 and hit really high transaction per second. So and typically we don't see more than 20, although there are, scenarios where that can change. So again, just increasing the capacity, you should actually look at that. If you have a crazy high capacity on your service, that would be the first thing that you may want to do in terms of modification in order to perform in a better transaction per second. And I we'll take one last question because we are a little bit over time today. If you do have further questions, you can ask on the community or reach out to Andrew or I directly. Andrew, do you want to take this one?
So if you're looking, so we're talking about the prod data for more realistic testing. If you're looking at a realistic test, oftentimes what you're looking for, especially if you're doing, say, a day-long test or a production test, you want to analyze a couple things. Do you have spikes, for example, when systems come online in the morning? Is there an end-of-day spike? What is the general layout of your transactions during the day? If you have failures that are slowing your production system down, you kind of want to get an idea, or do they represent 1% of your transactions? Do logins and small transactions represent a certain amount? And then what you want to do is you want to build virtual services. So what I find most efficient is actually build individual virtual services with a single transaction per size. So say, for example, you might have an order acceptance service, and there might be orders coming in that are 1K, orders that are large that are 100K. Your first reflex might be to build the single service with multiple transaction types that match differently. But what I find most efficient is to build individual virtual services for each type, and then kind of work your load harness to be able to send as many transactions as representative of your goal. If it's a Black Friday style level of transactions, or if it's a low level during middle of the week during an off month. It just depends on what is your goal of your production test.
And I want to thank everyone today for joining. I realize that there may be some more questions. If you can, we're having office hours coming up. So if you're able to join us for office hours, we can talk more about your specific questions, together. You're also welcome to ask on the community or reach out to us directly. We're a little bit over time, so I want to thank everyone, and I apologize we weren't able to answer all of the questions today.
Okay, thank you.